Okay. So I'll say.
One more thing for my sake, and
Yeah.
then you guys can do your thing. Can you look at Michael?
Can I look at him?
Yeah.
Are we supposed to look each other in the eyes?
Oh yeah. Look at me, David.
Yeah.
I'm not going to look at you. Hi, and welcome to Factbird's Manufacturing Matters podcast. I'm Michael, and today we're going to talk about buying sensors, basically, and how to select sensors based on cost versus performance. So we're going to have some tips around that. And we have David in to talk about that. So David's got a lot of experience with sensors. Hi, David.
Hey, how we doing?
I'm good. Yourself?
Hey, living the dream out here in Copenhagen.
Yeah, visiting. Could you tell us a little bit about yourself?
Yeah, so originally from the upstate New York area, now living in Charlotte, North Carolina. Been around the manufacturing world for 8 years or so, working with different technologies such as, basic sensors, photoelectrics, vision equipment, 1D, 2D, 3D measurement, inspection technologies, traceability. If it goes on a manufacturing line and helps the process move along, I've probably sold it to you, or somebody for that matter.
Excellent. Yeah. So David's our guy regarding sensors. Everybody needs sensors in some way or another when they're making stuff at scale.
Yeah.
And there's lots of good considerations to make there. So first of all, why is it important to consider cost versus performance when you're purchasing a sensor and not just taking maybe the cheapest one off the shelf?
Yeah, I'd say the biggest thing is because of the cost of the sensor is not just indicative of what you're paying for the actual hardware. When we think about manufacturing, there's a lot of drivers that go into cost, and specifically, and most definitely the biggest is downtime. If the sensor that you select to do a specific application is failing at that application even one time a day and causing you, let's see, a minute of downtime. That minute of downtime can, in some operations, outweigh completely the cost of buying the more advanced technology for that application. And sometimes, we in the manufacturing world, we'll see that initial price tag, and we do this in our everyday lives as well. Cheaper seems better, whether that be a new pair of shoes that you're buying that might tear 2 months down the line. But when you initially buy it, you feel really good about it because you thought you got a deal.
Yeah.
But it's that reoccurring cost of maybe buying that new shoe or the downtime that comes with buying that cheaper sensor that is kind of the hidden cost behind it.
Yeah.
So bringing into consideration not just the upfront purchase cost, but what comes after the fact is something that we really need to consider when especially purchasing sensor technology, because I've worked in industries where an hour of downtime is worth, $500,000 worth of production value.
Yeah.
So,
Do you have an example of how that can happen? Because at Factbird, for us, sensors come into the game mostly when you're measuring production, right? Or counting or, checking temperatures or whatever. But so how can a sensor cause downtime?
Yeah. So let's say we need to, detect a bottle coming down a manufacturing line, and our sensor is trying to hit that target, but is repeatedly missing it, or maybe misfiring and triggering when it's not supposed to. So it's not seeing something, but it's saying I am seeing something. Usually that sensor is driving an action. So let's say in this case, putting a sleeve or a label on a bottle.
Gotcha.
And if we're misfiring or not firing that sleeve, we now have a quality error or we're wasting material.
Yep.
So very quickly that begins to add up in downtime costs because somebody's got to go over, shut the line off, and then readjust that sensor so we are operating in the way that we're supposed to be.
Yeah.
We at Factbird maybe use sensors more on a counting basis.
Yep.
But sensors really go a lot deeper when you're thinking about practical applications on a manufacturing line. They're your eyes. They are seeing where the product is, where it's placed, so that an action can also happen.
Yeah. Yeah, and then you have that data wherever you are.
Yep.
Yeah. Awesome. And I thought of another question actually while you were explaining the importance of cost versus performance is, do people have brand loyalty with sensors? It was just like you had that little analogy with shoes, right?
Yeah.
And I know with shoes and lots of commodities like that, people focus on brands. Does that happen with sensors as well?
Absolutely.
Absolutely?
Yeah, there are plants that if you try to walk in the door with a different brand than what they typically use, they will quickly shoo you away. We are a Kian's house. We are a Omron house. We are, we work with Contranex. Whatever that brand may be, usually they have a loyalty to them, and in some instances it makes a lot of sense. because when we think about, sensors and standardization on a manufacturing line, when that sensor breaks, we have to replace it.
Yeah.
So if we have 15 different vendors in the door, we now have 15 different manufacturers that we now have to buy from. We need to allocate stock in our tool crib too. And you're trying to manage a lot more people in that sense, and also stock of articles to keep your plant running.
Yeah.
So a lot of people like to standardize off the fact that it makes it easier. It's coming from one sole source.
Yeah.
There's one person that we have to manage, one sales guy like myself that we have to deal with.
Yeah.
Because at the end of the day, not everybody loves dealing with a sales guy.
Yeah. Well, some of them are pretty good though. Yeah.
We like to think so.
Nice. Yeah, that's super interesting. Yeah, that makes so much sense. So yeah, you want to keep it simple. Don't have too many different brands in the house and people to deal with and stuff like that.
Yeah.
I guess like for Factbird, we're sensor agnostic, so we don't have any skin in the game here, really. So this is really general advice. And we're like sensors don't typically have an issue with interoperability, right? So it doesn't really matter which type of sensor you have. They use the same sort of communication methods. But then it does make sense to stick to one, because then you've got that simplicity if something breaks or you need customer support or whatever.
Yeah, your maintenance team, your operations team that are running the line understand how to program that sensor, how to work with it and maintain it. You're not having to train them or have them call people all the time when these things go down. So it's standard practice. They know how to go in, unplaced, replace the cable, take the sensor off, and reprogram that new sensor. So having some level of standardization helps reduce the amount of time it takes to replace something.
Super interesting. So yeah, that's why cost versus performance is important. So what do you need to actually then consider when you're choosing sensors for your production lines?
Yeah, I'd say the most important things to consider when choosing a sensor for a production line is usually, number one, what is the target that we're trying to hit? Is that a solid material? Is it a transparent target that we're looking for? Is it a contrast-based sense that we're trying to make? So think of a registration mark on a...
Yeah, like QR codes or the registration marks. Yeah.
Yeah, maybe we're trying to see that in a moving calendaring process. And calendaring, for those that don't know, is just a continuous web. And maybe we want to cut it so that we have the right wrapper to go around a bottle.
Okay, yeah, because I did not know what that meant. Okay, yeah.
And you want to see that registration mark because that's where you're going to make the cut on that wrapper. That would take a different sensor than just trying to see this pen going down a manufacturing line.
Is that like a camera detecting that, or it's just the contrast it's looking at?
It can be both.
Yeah.
There are certain sensors that can just read standard contrast change, so from black to white maybe. So seeing that registration mark, but sometimes you might use vision because that contrast that you're looking for might be moving around a little bit more than a sensor can pinpoint directly.
Fascinating. And then you said like a standard target versus a transparent target. How can a sensor detect something that's transparent?
A very good question.
Yeah.
Transparently, I could dive really deep into that, but the basics of it are, they have specialized light emission and bounce back that is happening in each sensor. So some are optimized to see more matte targets, and some are optimized to see, where that light disperses a little bit more when you're hitting a transparent surface. So they might have more light being pushed out to the surface material so that they get more light back.
Yeah.
It's a rather complex topic, to be honest. It's a deep rabbit hole that we could probably do a whole podcast on, if I'm honest.
Maybe season 3.
Yeah, we'll get there.
Okay, we need the content. But then does that change the cost? Like, so if you're just shooting light at a can and you're seeing it bounce back and detecting it versus a transparent object, would that change the cost of the sensor? Or?
To some extent, yes. Okay. A lot of the times a transparent target sensor will have a little bit more upfront cost than, like a standard matte target sensor.
Yeah.
And that's just, based on the fact that they know that they have something a little bit more special that they've created. So the technology doesn't change innately a ton, but it definitely is the engineering work that went behind that sensor that hiked the price a little bit.
Yeah. And then do people in factories know this? Like, do people quite often make the mistake of getting the wrong type of sensor, or from your experience, people quite good at doing like proof of concepts and testing before scaling?
It's complex. I will say there are times that companies do a really good job with this. They will test the sensor on their physical manufacturing line for weeks or months before, really letting that loose as their full standard across the factory. And then there's other customers that I've seen that, a guy like me walks in, we sit inside of a meeting room and I show you, my fancy sensor. It turned on when that target was hit.
Yeah.
You should buy this.
Yeah.
And I mean, a lot of things will work really well inside of a meeting room. When you get into a production environment and you've got, environmental influences that you're starting to deal with, like condensation on the front of a sensor's face, dust or dirt in the environment because things haven't been cleaned or PM'd. These are things
PM'd?
that preventative maintenance.
Ah, gotcha.
Yeah, they haven't gone through their routine of, every 1,000 cycles we got to go rub the face off just to make sure that there's nothing on it.
Yeah.
And these are things that we don't really consider when we're, sales guy comes in, tries to sell you something flashy and new. We sit in a room like this and we demo it on a table.
Look, it's counting stuff.
Look at how well we're doing.
Yeah.
And it's not until you get into the nitty gritty of the manufacturing environment that you can really understand, is this going to fit our application long term? Because anything will work great if it's, on a desk. It's once you see, the sensor getting hit because somebody was trying to clean it, now it's not aimed the right direction. Things like that will start to influence, as well as environmentally, the actual performance for long-term longevity.
Yeah, I've seen notes as well on some sites about don't cover the sensors or don't move them when cleaning and all these, or cover them when cleaning and stuff. And that actually brings us really well into our next topic, right? So as you said, like one thing is getting the right tool for the job. So being really aware of what you're sensing and the possibilities of how to do that. We've got content in other places talking about all the different types of sensors, like flow sensors and whatever. But then the other big thing to consider is the environment in which the sensors in.
Yeah.
And so could you give us a breakdown of some of the key environments that might be difficult or easy with sensors?
Yeah, for sure. I think the most difficult one that I've personally worked with, and this comes from my background in the automotive space, was welding and stamping. You have very large hunks of metal being pressed on at a very high velocity and as well being welded on with very high heat, almost molten lava flying around in the environment. So you have a lot of heat and, I guess, violent kind of molten metal flying around that can affect anything, from a sensor to the fixture and everything in between that's going on in that environment. So when we think about that side of, environmental influence, it can be really difficult to have something that's, going to stand the test of time where there's 300-degree magma flying around.
Yeah, not many things equipped to deal with melted metal flying around the place. So high heat environments. So what do you do there? What's the solution for that?
It's really, thinking about the innovation in the marketplace. I mean, we've come a long way when it comes to technologies because, we've started to notice these things for a long time. And this is going to a specific sensor in that industry that's used quite a bit is inductive proximity. And what that means is it's a sensor that only sees metal. So when metal's there, it says, hey, I see something. When metal's not there, it doesn't see anything. And for a long time, there was only really metal-bodied and plastic-facing versions of that sensor. And within the last 20 years or so, they have innovated, the ability to sense through a metal face with a sensor that's seeing metal, which complex problem. The sensor wants to see metal. Now you're putting a metal face where the sensor's looking. So that took a while to really manage, but that innovation came by, and now you have a sensor that's made of full stainless steel. So you take it, put it in a hammer, and you can smash it on things, and that sensor doesn't break.
Cool. And then the cables coming out of it and stuff, how do people deal with that?
I mean, there's cable wrapping that you can put on to try to protect it, high heat Teflon or, stainless steel coverings that you put over those cables to try to protect it from the, molten magma flying around, because even one little BB of that weld gun hits that cable. It's going to burn right through it and short the circuit, and you have a maintenance guy out on your floor.
And downtime, that's very expensive.
Yeah, in that industry specifically, I worked with plants that would see, $22,000 a minute in downtime costs.
That's insane.
And to replace a cable and a sensor, you're talking about 15 minutes, you're losing hundreds of $1,000s in production.
And just as like a ballpark for the figure, like what would this sensor with a stainless steel front and a stainless steel casing and maybe Teflon cable like roughly cost?
We'll say, all in with the protection that you need on the cabling, the bracketing, and the sensor itself, you can be in that upwards of, $250 for everything all in versus, the plastic solution that, man, you might be able to get it for, $20 for the sensor, $10 for the cheap cable, and, you've got a $30 solution.
But it's not the cost of replacing it, it's the downtime that it's causing when you're replaced, because that's crazy. Like what was it, $22,000 a minute?
Yes.
Yeah.
Which is egregious. I mean, we think about, yes, I saved $200 on the sensor, but if I replaced it, 6 times in the last year at 15 minutes a piece, we've lost a hell of a lot more money than we actually gained on buying the cheaper product.
Yeah, that's a very expensive little plastic sensor.
Yeah.
Okay, cool. That's really fascinating. So that's a high heat environment. Are there other sort of key environments to consider?
Yeah, for sure. I'd say specifically for, kind of our unique market that we work within, food and beverage, consumer packaged goods.
Yeah, that's like our bread and butter when it comes to our customers.
For sure.
Yeah.
We're working at more of a washdown based environment. So, at the end of the day, we have to clean all of that equipment off so that, there's no mold or mildew being created on the actual manufacturing line. So intensively, there's people walking around with, think of a car wash hose that you spray a car with.
You're like a high pressure hose basically, right? You just
And they're going around and spraying the entire factory with that stuff. And most of the time, the people doing that don't really think about the sensor that's sitting on the line. It's just another piece of equipment, and we need to clean this all. That's my job, is to make sure there's no mildew.
Yeah, which is fair. Like they should expect like everything in here needs to be clean, and I should be able to clean it with the tool that I have.
Yeah,
Yeah.
certainly.
So what's the solution there?
Simply speaking, I mean, it's just going into solutions that have the proper IP ratings. So when we think about sensors, there's all different types of ratings that you can achieve. IP69K is really, if you're working in a washdown environment, you got to be up in that IP69 to 69K.
Yeah.
Because at the end of the day, that's the kind of solution that can really withstand the beating of high volatility of water and washdown, and they're hermetically sealed. And what that means is just water cannot seep into the sensor itself to cause an electrical short.
Thank you for that.
Yeah. Did you know that?
I've heard the word hermetically sealed before, but I was hunting around in my mind, like, what does that mean? So it's good to get the definition straight away. So IP69K, so that's what you need when there's like a high pressure water flying around in an environment, really.
You don't need to have it,
Yeah.
but I think it'll make your life a lot easier to have that level of protection on the sensor level.
Yeah, so it's that long-term sort of saving versus the short-term saving of buying a cheaper sensor, basically.
Yeah, 100%. It's the same thing as the high heat environment. I mean, in that world, I would see people replacing 1,000 to 1,500 sensors a year.
That's insanity.
It's a lot. High pressure environments, it's definitely a little bit reduced. I'd say automotive stamping and welding was the most volatile. That's where people lost the most. But very corrosive environments from a chemical and cleaning perspective can really degrade sensors very quickly as well. And at the end of the day, with high volume production manufacturing facilities, again, the downtime is very costly. So,
yeah, you got so many other moving parts happening on your line. You don't want to be worrying about sensors.
No,
absolutely
not.
Minimizing problems. Okay, yeah, so that was a high heat environment, sort of washdown environments, predominantly in food and beverage, stuff like that. What other types of environments?
There's a couple more that you could get into. More nitty gritty would be like high pressure environments. So when we think of like hydraulics or bigger maritime systems, those sensors have to be able to withstand, a certain pressure of bar that might be happening within the environment. If you don't, it's simply just going to crack and explode pretty much.
Where and why would a sensor be placed in such a high pressure environment? Like, what's it doing?
One example that I have that, I did an application for with a customer was for military missiles on a submarine.
Okay.
And this sounds very extreme, but you're in a submarine under extreme pressure, and they need to be able to see, that the missile was loaded into the actual firing chamber for that submarine.
That's important.
Very. You don't want your gun to go with nothing coming out.
Yeah.
It'd be a sad day.
Yeah.
So being able to sense and make sure that missile has been properly positioned, is in the right location in an environment that's extremely high pressure is something only a very specialized solution would be able to enable.
Yeah, that's a very, that's certainly one end of the spectrum sort of example. Are there any other sort of like high pressure environments, like on a production line where?
You would see that in, tanks, larger tank applications. You would need a pressure-based sensor, especially, if you've got a ton of water siloed inside of a tank or milk, any kind of, just liquid.
Yeah.
At the end of the day, the bottom of that tank is going to have a large pressure buildup.
Yeah.
So you're going to want to ensure if you're cutting a hole in that tank and using that sensor as kind of a floodgate stop, but also something to sense that the material is there, you would want a high pressure sensor in an instance like that.
Yeah, and there's this whole story of, like with digitization, there's more and more sensors out there. There's sensors everywhere now, right? I think like at the top end of the spectrum, well, there's the military stuff. There's also the like the wind turbines and that. When you've got these offshore wind farms, I think they've got like 20,000 sensors in one wind turbine.
Yeah.
And that's because, if you fly somebody out there to do maintenance, that's like $50,000 an hour or something crazy.
Yeah.
But that's where lots of things are heading. So even in food and beverage production, sensors everywhere. So we've got an open invite to go visit the Albani production line customer of ours. So I might ask where they have sensors, if they've got any sensors in tanks and stuff like that. Yeah. It's a brewer. And yeah.
Can I come?
We'll try to wing that. Yeah, talk to Benjamin about it. Cool. Are there any other interesting environments where sensors might be placed that are produce like unique problems?
I would say one that I specifically have run into within, again, this is the welding industry, but also if you're, by machining, CNC equipment, electromagnetic interference becomes a problem at times. And this is specifically, through the wiring. So certain machines, and this can also happen in food and beverage near like x-ray equipment.
Yeah, you always have that at the end of the line, right? Checking. Yep.
There might be a lot of electronic, there might be an EMI field being created by that machine. And in that instance, technology around it starts to get disturbed from a signal perspective. So there are specialized solutions that can see through that electromagnetic interference to specifically be used in those styles of applications. Because, again, if your sensor is triggering a lot more than you want it to, which will happen if there's magnetic fields, it's bad. Yeah, you want your data to be reliable and things not to operate or not operate when they're not meant to or whatever. Yeah. Okay. I've learned a lot. That's really fascinating. But if we're going to boil it down to one thing, like what's the one piece of advice you'd give manufacturers out there or our listeners out there when purchasing sensors? Like the main thing. I'd say the main thing, and to be very blunt about it, is don't be cheap when you're buying your sensors. Yeah. They might seem like a low-cost solution and something that's very simple going into your factory, often overlooked, but they can cause a lot of pain on your back end that you might not see or be able to visualize. Unless you're using a service like Factbird, we can help you, see that data a little bit more forward. Salesman. Yeah, a little bit. But yeah, very much so. Do your research, negotiate with your vendors, and don't be cheap when you're buying your sensors. Yeah. Pick the right application for that technology. Awesome. Thank you very much, David. That was awesome. I'll try to grab you next time you're in Copenhagen visiting us in January, I think. Yeah. For another podcast. If anybody listening out there has questions for David, actually you can find him on LinkedIn or send us an email via the factbird.com contact us page. And if there's any topics you'd like us to talk about in the future, feel free to write as well. Yeah. Thank you, Michael. It's been a pleasure. Thanks, buddy. See you next time. Yeah. Cheers. Cheers. And that's good. Good episode. I'm happy. Gabriel's going to turn that. Yeah, okay. I'm not doing this anymore with the camera thing. I'm over it. It's soft.